Hey guys, welcome back to my channel. In today's video, we are going to see how to find whether a number is odd or even, right? So the question is straightforward and we just have to say if a number is odd or even, right? So let's look into the question, but we have to make sure that we should not be using this modulo operation, right? So the traditional way is very simple. We will just do something like n modulo b. If it is equal to 0, that means it's an even number. If not, it's a odd number, right? So it's a very simple approach, but we are not going to use that approach, right? So what if I say you should not use this modulo operation, right? So try thinking something else. Try to think something else. I want you to pause this video for a moment and then think a while, and then after that come back to this video, right? So I want you to observe something in this. So here are some numbers. Here are some numbers, and these are their binary binary representatives, right? So can you observe something here? Can you observe something here? One is an odd, one is having a binary number 0001 and it's odd. 2 is 0010 and it is even. 3 is 0011 and it is odd. Similarly, 10 is even, 5 is odd, 7 is odd, 9 is odd, right? Can you observe something in this? Node in this table? Can you observe something? Can I say that for all the odd elements, the last bit is set? For all the odd elements, the last bit is set, right? So here last bits are set, right? And for all the even numbers, last bits are unset. Last bits are unset, right? So the last bit is unset for even. So for even, last bit is 0, and for odd, last bit is 1, right? So will it be true for all the test cases? So will it be true for all the nums? I'm saying yes. Let's see how. So to understand this, you have to understand how binary number system works, right? So let's say a binary number is given, let's say 1010. I am saying the value of that number is 10, right? So how you go to know that? So let's break down, right? I will write the same thing, something like this, right? In the zeroth place, I will write the bit and then I will do into 2 raised to 0. Then for 1, 1 into 2 raised to power 1. Then for 0, 0 into 2 raised to power 2. Then for 1 again, 1 into 2 raised to power 3. Right. So the answer will be, this will be giving 8. This will be giving 2. So 8 plus 2 will give 10. So that's how we got 1010 as 10. Right. So if you observe something, in the rightmost bit, it will be 2 raised to power 0 and then 2 raised to power 1, then 2 raised to power 2, then 2 raised to power 3. Like that, it goes on, right? So the values will be 1, 2, 4, 8, 16, 32, something like this. So let's say a number is given, for example, 1, 0, 0, 1. So it is basically 8 plus 1, which is 9, right? So I want you to notice something here. I want you to notice something here. So all the numbers except this number is even. So what I am trying to say is that all these elements are even, right? So 2 raised to power something, let's say x, 2 raised to power something will give even if x is greater than 0, right? So if x is 0, 2 raised to power 0 will be giving 1, right? So the rightmost bit, that's the only bit that is having a odd number, that is 1, and rest all the bits are having representation of even numbers, right? So that's the reason I'm saying if 2 power 0, that is the last bit, is set, it means that 1 is added to the answer, which is the only odd value, right? So I can say that if the last bit is 1, it's an odd number. If the last bit is 0, it's an even number. Now I want you to have a look at this, right? So binary of 1 will be 0, 0, 0, so on till the last second index it will be 0 and the last index will be 1, right? So binary representation of 1 is this. So to check for a number if the last bit is 1 or not, I'm going to do some operation with that number and 1, right? So what should I do? What should I do in order to get this result? I will be using AND, right? So AND will only give 1 if both are 1, right? If this was 0, the answer would have become 0 again, right? So let's look at this example. Let's say 6 is the number. So the binary representation is 0, 1, 1, 0. So last bit is 0 and we are doing AND operation with 1. Now in this position 0 and 1 will give 0, right? Hence the output will be 0. You might be wondering why I am only explaining about the last digit, because these digits, no matter what comes in the real number, these digits will convert them into zeros, right? Because both of them should be set in order to get an output 1, right? So since all these are zeros, I can conclude that all these will be zeros, right? So this one will check for the last index. So if it is 1, this will give 1. If it is 0, this will give 0. So can I say something like n and 1 will give 1 if it is odd, and n and 1 will give 0 if it is even? Yes. So that's how we are going to solve this problem, right? So the code is very simple. N is given to me. I'm just checking whether n and 1 is equals to 1 or not. If it is, I'm returning odd. If it is not, I'm returning even, right? So it's a very simple code, but it's very important to understand how these things work internally, right? So that's it for the video. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.